Is going on, guys? My name is Amos and welcome to your very first computer networking video. So in this video we want to introduce the concept of computer networking. Now if you like the video, be sure to give it a like and subscribe to this channel. In the video description is a link to a site of which has notes of whatever is going to be talked about in this video. Now before we get the ball rolling on what computer networking is, let us first of all try to understand some situation. So now this is an interaction between Lisa and her best friend Mary. So Lisa has a list of items she wants to buy. All right, now here is the list of items Lisa wants to buy. Now Lisa does not have money to buy the items, to buy these items, so she decides to call Mary. All right, so Mary, it was a good day, so Mary had some cash, so Mary decided to give Lisa some money so that Lisa can buy the items she wanted to buy. All right, so Lisa and Mary, now this is a very simple situation, but it is going to form the basis of our understanding of what computer networks are and what computer networking is. All right, so Lisa has the money. Now, without loss of generality, let's say that Lisa is in town A. Lisa is in town A. Mary is in town B. So Lisa and Mary are connected via a phone call. All right, connected via a phone call. Then Lisa calls Mary. All right, Lisa calls Mary so that she can ask for some money. Now, Mary wouldn't have known Lisa needed money if Lisa hadn't called. All right, Mary wouldn't have known that. And Mary responded by giving Lisa what she asked for. Now, Mary didn't give Lisa cartons of milk or boxes of candy. Mary gave Lisa the money. All right, she actually sent the money to Lisa because Lisa is in town A and Mary is in town B. All right, and yeah. And Mary sent the cash because sent the money because Mary had the money. If it was a bad day and Mary didn't have the money, Lisa wouldn't have gotten that money. All right. Now, computers can communicate in a very similar manner. All right. So for two computers to be able to communicate, they have to be connected in some way. All right. Now, there are many ways in which computers can be communicated. Now, the most common ways in which two computers can be connected is via what is known as coaxial cables and Ethernet cables. All right, Ethernet cables. Just like Lisa and Mary were connected via phone call, computers are connected via these very, very popular ways. So using coaxial cables and using Ethernet cables. Now, the group of computers that are interconnected, in this case we only have two computers. Eventually we'll have more computers we want to connect, because the goal is to connect as many computers as possible. Now, because the most concrete of all the reasons of establishing computer networks and interconnecting computers is to share resources. Now, a resource can be anything. It can be a device such as a printer, a scanner, and many other things. All right. Now, here we have two computers. All right. So we can connect them by using coaxial cables and Ethernet cables. Now, these computers form what is known as a these computers form a network. All right. A network of computers. Now, computer networking is actually the process of connecting these computers to each other via connection media such as the coaxial cables and the Ethernet cables. All right. Now, for the purpose of this video, we're going to use an arrow. All right. We're going to use a double arrow to represent that, to show that two computers are interconnected. All right. Now, the various computers connected in a network are known as nodes. So this can be your node 1, and this is your node 2. All right. Now, like I said earlier, we can connect as many computers as we want to in a particular network. All right, we just have to figure out how we're going to do that. Now, the technical term for the different kinds of ways of connecting computers in the network is what is known as a topology. All right, so we have different kinds of ways of connecting computers. So we technically have different kinds of topologies we can establish, and by establishing these topologies, we create different kinds of networks. So that is going to be the purpose of this video. Now let us look at a number of ways we can use to connect computers, technically known as the topologies. So we have the first one, which is known as a bus topology. So what is a bus topology? So all the computers in this network are going to be connected via what is known as a backbone cable. All right, so we actually have a central cable, which we are calling the backbone cable, and then all the computers or all the nodes are going to be connected to this central cable. So communication is via this backbone cable. So let me just draw the nodes. All right, so we have this is our node 1, this is our node 2, and now node 1 and node 2 can be anything. Node 1 can be your PC, node 2 can be your printer, and node 3 can be your Mac, and you can have many devices. All right, now node 3 and node 4. So we have 4 nodes in this network. Now this is our backbone cable, so communication is via this backbone cable. So if there's any problem with this backbone cable, the network is going to fail to operate. So we won't have any communication between the various nodes of this network. Now to prevent signal reflections, we put terminators at the end of the central cable. We put terminators at the end of the central cable. Now, what signal reflection is that once a signal is sent, let's say the signal is sent from node 2, all right, and let's say node 4 is a printer and the signal is sent from my PC, which is node 2, all right. So signal reflection happens when the sent signal tries to get back to where it came from, that is node 2. So that can cause what is known as a transmission error, and it's actually going to affect the overall performance of our network. So what do? We put terminators at the end of the backbone cable to prevent signal reflection. Now this is a bus topology. If the central cable has a problem, then the network is going to fail to operate. All right, and yeah, but if we don't put our terminators at the end, we are going to have signal reflection. The network might work, but we're going to have a transmission error eventually, and that is going to cause our network to that is going to affect the overall performance of our network. So this is what is known as bus topology. So it's a way of connecting computers where we have a central cable to which the different nodes of the network are connected. It's very simple to implement, but it's not the best way of connecting computers. Now, if you have a lot of computers and you connect them in this way, you eventually run into many problems. If you have just 4 computers, 3 computers, maybe 2 nodes, it can actually work for you, but it's not the best way. So the second type of topology we want to talk about is a star topology. Now, for a star topology, we have a central device to which all the nodes of the network are connected. Now, communication is going to be via this central device. Now, the central device can be a switch or a hub. We'll talk more about network devices in the following videos. But in this video, let's assume that this is our switch. All right, so a switch is a network device. We're going to talk about the differences between a switch and a hub in later videos. So this is our switch. So to this switch, we connect the different kinds of nodes we want to connect. So let's say this is my network structure. This is my network structure, and this is my node 1. This is my node 2, and this is my node 3. My node 3. So this is node 4. That is node 1. Then this is node 2. And this is node 3. This is node 4. right? So all the devices are connected to one central device. So communication has to be through this central device. So if there's any problem with this central device, then the network is not going to it's not going to work. It's not going to operate because this is responsible for handling our for handling our transmission and so on and so forth. Communication is through this central device. But let's say if there's a problem with node 4, the network is still going to work because communication is through the central medium, through the central device, and not the nodes respectively. So node 2 can be your printer, node 1 can be node 2 can be your printer, node 3 can be your PC, node 4 can be your Mac, and node 1 can be your server. All right. So this is what is known as a star network or a star topology. It's actually a way of connecting computers to one central device. Now, the last type of topology we are going to talk about is what is known as a ring topology. All right. So, ring topology. So, for a ring topology, network nodes are going to be connected in a secular manner. So let's say this is my node 1, this is my node 2, and this is my node 3, this is my node 4. So secular manner. So we have this. Now, this is your node 1, and then this is your node 2, and then this is going to be your node 3, and this is your node 4. So if node 1 makes the request, maybe let's say node 1 wants to talk to node 3. All right. So the signal is actually going to be sent. These are not written in order. So let me just put them in order so that we can be able to make sense of whatever is here. So this is your node 2, and this is your node 3, and this is your node 4. All right. So the signal is going to be sent from the source. Let's say the source is node 1. If node 1 wants to communicate with node 4, so the signal has to go through node 2, through node 3, and then finally through node 4. And then the response is going to be sent. All right. So this is the path that signal is going to follow. Now, if there's a problem with, let's say, node 3, if there's a problem with node 3, it means the network is going to fail. All right. So this is actually because of the mechanism of communication that we have established here. It is going to be slower than the star network or the star topology. All right, because we actually have to reach our target, and we have to go through all these nodes for us to be able to get to our target. So that can actually make our network slower than what is known as a star topology. All right, where communication is via the central medium. And then if a certain node is failing, then the network is going to fail. All right. So that is what is known as a ring topology. So whenever we have many computers connected in a particular network, we actually come up with different types of networks. So we have what is known as a local area network, or a LAN for short. So LAN, or local area network. Now, this is an interconnection of computers over a very small area, such as a room or the same building. So this is a local area network. All right. So whenever we connect our computers within a small area, let's say a room or a building, so we actually come up with a local area network. The second type of network that we can come up with is a MAN, or a metropolitan area network. This actually spans a greater distance than a local area network. For example, you can connect computers in the same district. So you actually come up with a MAN. All right, a metropolitan area network. Hopefully, I'm going to spell this one correctly. Metropolitan area network. Metropolitan area network. All right, and then we can eventually have what is known as a WAN. So a WAN is a wide area network. wide area network. Now this is going to span, of course, the greatest distance of them all. So this is when you want to connect computers in the entire country. Now generally a WAN is an interconnection of many local area networks. So an example of a WAN is a network that is going to connect the entire country, for example, like the entire continent. So you're going to have a wide area network. So thank you guys for watching, and I'll see you in the next video.